Hey, what's going on, guys? Let's do this problem right here. The first question is asking current in the circuit. So let's see how we can find it. So how we can find it is here we can create the loop equation. So what we have, if I take this rotation and I can pick any point, right? So this is, let's say, loop, right? So I can pick up any location. Let's pick up this one. And according to Kirchhoff's second law, we know that sigma loop is equal to 0. Loop is equal to 0. So all we have to do is just add them together and solve for I, right? And I is going to be equal in all of them since it's in series. The charge, since if it's in series, charge is equal. So current is basically charge per second. So therefore current also equal, right? So let's go ahead and create the equation. First we have, if we go through this one, we have 6 volt going from negative to positive. So we are going to have a positive 6 volt. And then if I take current this direction, we can assume any direction, and if the answer is negative, it means our assumption is wrong and it's going through the opposite direction. So let's assume both are going in this direction and create the equation. So here if I assume this direction, this is going to be minus I1. We know that V is equal to IR. So here I times R, right? We know the R already, that's 4. So this is going to be I times 4, and then let's use a different color, maybe white, yeah. And then we have I times 8. Then we have this one going from plus to minus, so this is going to be negative. If it's going from plus to minus, it's negative. If it's going from minus to plus, it's positive. So plus to minus negative, this 12 volt. So it is going to be negative 12 volt, that's equal to 0. So this is the sigma V loop, right? Voltage loop is equal to 0. So here we have this equation. Let's solve this one. So let's forget about the unit for now. I don't know. Okay. So let's move this, both of them are this side. Negative 4i, negative 8i, that's going to be 12i. And here we are going to have minus 6 minus 12, minus 6. Therefore I is equal to minus 6 over 12, and that gives us negative 0.5 ampere. So that's going to be the answer for the first question. So this is A part. So let's do the B part. B and C part asking power dissipated in each resistor. So to calculate this one, what we do, we just take this current and multiply by the resistor. We know that V is equal to IR. So here what we are trying to find, we are trying to find power. Power is equal to P is equal to VI, right? So VI, since we don't have the voltage in this resistor, we can use this one. V is equal to IR, and if I replace V with IR, this is going to be IR square. So this is what we are going to have, and let's plug this one right here for this resistor right here, R1. So let's say this is P1. P1 is going to be IR square. So we have negative 0.5. Actually this is I square R, right? Because we are replacing this V with IR. So this is going to be I square R. Here we have negative 0.5 square R is going to be 4. So I square, this is same as 1 by 2 square. We know that 1 by 2 square is going to be equal to 1 over 4. So this is same as that. 1 over 4 times 4, that's going to give us just 1. So the power at this one is R1 is 1 watts. And let's look at the power at R2. Let's say P2, so the C part. So here we are going to use the same equation. P2 is equal to I square R. And I square we already know, that's 1 over 4. And then R is 8. So this is going to give us 2 watts. Let's do the next question. Okay, now here we have DEFG. The question says the energy transfer rate of each battery starting whether supplied or absorbed. Okay, stating whether supplied or absorbed. So we assume this direction, right? Current this direction, but current is actually going through opposite direction. So whatever the, okay, let's find this one first and then plug the charge. So first let's calculate for EMF1, that's 12 volt. So if we calculate the power, so energy transfer rate means power, right? Energy per second, joules per second is equal to watts. So the question is asking for the power in each battery. So let's apply for the EMF1. EMF1, let's say that is power prime. So power prime is going to be V, again, here we are going to use VI. So V is 12 watts times 0.5, that's going to give us 6 watts, right? And now we have to know whether it's positive or negative. We previously we assumed this direction and got a negative value. Here if you notice, this is a negative value. This means current is not flowing in this direction. Actually current is flowing in the opposite direction, right? It should be in this direction. So if this going through this direction, this is going from negative to positive. You see this one, negative to positive. So this value should be a plus value. That's why this is plus 6 watts. And let's look at the other one, this battery, and see what value get. P prime, that's 6 times 0.5, that's 3 watts, right? Now if you see, current is going through this one and this is going from plus to minus, so that's going to be a negative answer. So this would be a negative answer, and that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.